this area. How do we calculate the area of revolution? That's our concern now. Now, take a small part of the curve of length ds. Now, if you take a small part of length ds here, that is very small, almost like a point, because only when the length of that ds is very small will it be equal to a straight line. And the length of such a small arc is given by ds equal to square root of 1 plus dy by dx all squared dx. That is the length of the arc. So if you take a small length of the arc ds, that will be its length. And if you revolve such, suppose this is the ds. This is the ds, which is very small. Tell me, if you revolve this about the x-axis, what are you actually generating? Well, if you revolve just a point, you generate a circle. If you revolve a line of length ds, you are actually generating the surface of a disc-like structure. Is that right? That's right. You're actually generating the surface of a disc. Not the whole disc, because the inside is hollow. The surface of a disc. That is what you generate by revolving that ds around the x-axis. So revolving ds around the x-axis, you generate a cylindrical surface, because the cylindrical surface inside is actually hollow. So this is what actually you generate. You see, if that is ds, if you revolve this about the x-axis, what you generate will be a surface like this. Now, what is the area of this cylinder? How do you find the area of the cylinder? The area of the cylinder is, if you look here, this is a circle. The circumference of this circle is 2 pi r, and that circumference multiplied by this length will give you the area. So 2 pi r multiplied by that length will give you the area. Now here, radius. What is the radius? If you look here, the radius of that ds is this length, which is f of x. And the thickness of the cylinder is ds. So if the radius is r of x, a function of x, so 2 pi r of x is the circumference multiplied by ds, and ds is this, will give you the area of this cylindrical surface. Now, that is created by revolving this ds, and there are hundreds of such ds you can revolve, generating cylindrical surfaces. Add all those surface areas, you will get the complete area generated by revolving this curve. And that's the method. Adding all those areas means integrate. So once again, revolving ds about the x-axis generates a cylinder of radius r of x. The radius r of x is that distance, which is the function itself, r of x equal to f of x. So the radius of each of the cylinder is f of x. Okay. The surface area of this cylinder is, you remember how we got the surface area? The surface area will be the circumference multiplied by ds. Will be 2 pi r of x is the circumference multiplied by ds will give you the area of such a surface. Now, therefore, dA will be 2 pi r of x times ds. ds is the length of the arc, and the length of the arc is this quantity. So that will be 2 pi r of x square root 1 plus dy by dx all squared dx. So in finding the area of the surface of revolution, the first thing we need to do is to find the arc length. Is that right? And of course, then the radius of revolution. And once you have dA, what all we need to do is integrate that dA from x equal to a to x equal to b. And therefore the total area is integral a to b 2 pi r of x times ds. ds is square root 1 plus quantity dy by dx squared dx. Alright. If the graph of f of x is revolved about a vertical axis, you see the equation we developed so far is revolving the area about a horizontal axis. What happens if you revolve it about a vertical axis? What kind of area you get? That will be 2 pi integral a to b r of x square root f prime x squared dx. So one thing you need to take care here, if the axis of revolution is horizontal, then the radius is a function of x, and the arc length will also involve functions of x. If the axis of revolution is vertical, then the radius, remember the radius will be measured from the axis, will be a function of y, and the arc length, the ds, will also involve functions of y. Now, that's very important to know. So, if the axis of revolution is horizontal, the area of revolution is 2 pi integral a to b r of x square root 1 plus f prime x squared dx. And if the axis of revolution is vertical, a equal to 2 pi integral c to d, let's not call it a to b, c to d r of y square root 1 plus f prime y squared dx. Let's do a problem using this. Set up and evaluate a definite integral for the area of the surface generated by revolving the graph of y equal to square root of x about the x-axis on the interval 1 to 4. Alright, first of all, draw that figure and see how that curve looked like. Y equal to square root of x is something like this. And you need to revolve it about the x-axis. And this is the equation for the area of the surface generated by revolving a surface about a horizontal axis. Now, what are the information you need? Starting from here, we have f of x. This is y equal to square root x is f of x. We need to find f prime x. We need to square it. Then we need to add 1 to it. We need to take the square root of it. Now that is that quantity. Then the radius of revolution. The radius of revolution in this case will be y equal to square root of x. Alright, where do we start? We start with f of x equal to square root of x. What is the derivative of that? F prime x. The derivative of square root of x is 1 over 2 square root of x. Is that right? But you can also do it by using the power rule. Square root of x means x to the power 1/2. Or, I have told you from the beginning, learn this as a result that you need to know. The derivative of square root of u is 1 over square root u times u prime. The derivative of square root x is 1 over 2 square root x. So we've found f prime x. Now we square it. So what is f prime of x squared? Is 1 over 4x. Now you need to add a 1 to it. So what is 1 plus f prime x all squared? That is 1 plus 1 over 4x. Simplify it. That will be 4x plus 1 over 4x. We now need to take the square root of it. So square root of that will be square root of 4x plus 1 over 4x. And look at the way I simplified it. That will be, we split this into two square root quantities. Square root 4x plus 1 over square root 4x. Square root 4x is 2 square root of x. So that simplifies as 1 over 2 square root x times square root 4x plus 1. Now that is this quantity. Now what is r of x? The radius of revolution r of x equal to f of x, which is square root of x. So that is our f of x equal to square root of x, and the radius of revolution will be, when you revolve, that radius will be f of x. That's right. R of x equal to f of x. There you go. And therefore, let's bring it all together. The area of revolution is 2 pi integral a to b, which is given to us, 0 to 4. R of x is square root of x, and this quantity is simplified like this. So let's put it all together. That would be 2 pi integral 1 to 4, 1 over 2 square root x, well, r of x is square root of x, times this quantity. And you can see square root x and square root x will cancel, and the 2 and that 2 will cancel, leaving us pi integral 1 to 4 of 4x plus 1 and the square root dx. Now, can you do this integration on your own? What's the method? Well, the method is substitute the quantity 4x plus 1 equal to u, and when this becomes u, you need to replace your dx. What's the method? Take the differential of both sides. Differential of 4x is 4 dx. Differential of 1 is 0, and differential of u is u. 4 dx equal to du. Therefore, dx equal to du divided by 4. And so, when this quantity is replaced by u, dx will be du over 4. What else do we need to do before we write down? We need to change the limits using this substitution. When x equal to 1, that's our lower limit. When x equal to 1, this will be 4 plus 1, 5. U will be equal to 5. When x equal to 4, that will be 4 times 4, 16 plus 1. U will be 17. So change the limits. When x equal to 1, u equal to 5. When x equal to 4, u equal to 17. Just put those values of x in our substitution and find the value of u. So what is the area now equal to? Area is now pi times integral u changes from 5 to 17 square root of u times dx is du over 4. And now this 4 comes out, this will become pi divided by 4. So pi over 4 integral 5 to 17 u to the power of 1/2 du. You know how to integrate u to the power of 1/2 du. What is that? U to the power of 1/2 plus 1 over 1/2 plus 1, which is u to the power of 3 over 2 over 3 over 2. So pi over 4, u to the power of 3 over 2 over 3 over 2, from u equal to 5 to u equal to 17. Now, look at the way we can simplify this. 3 divided by 2, that 2 will go up. That 2 will cancel with the 4, leaving it 2 outside. So that will be pi over 2. And I can also take that 3 outside. Is that right?